Welcome back to Beginner's Breadboards, my electronics learning journey. Today we're looking at a bridge rectifier or a full wave rectifier. This is an AC to DC conversion or alternating current to direct current. So what we have here is just from the house, you're getting 120 volts at 60 hertz, and that's just the current that comes out of like any plug point in a house. What we have here is a step down transformer that takes what's coming out of here, the AC voltage, and just making it lower voltage. So out of that step down transformer, we're getting a 10 volt root mean square, which just means you're getting 10 volts AC. But from the peaks of the AC wave, which just looks like a sine wave, you're getting 15 volts from peak to peak. And that's just a little bit higher than the actual like voltage level of the AC current. Now, out of this, you're having the two leads, which are either positive or negative, just at either time. And what we take this AC current into is 4 diodes. We're using the 1N4001 diodes, and this is just a circuit where they're all connected up. The way this works is when this top line is positive and this is negative, the first diode conducts, it goes through the load, and then the third diode conducts. So it goes like that. And then when it's flipped and the top is negative and the bottom is positive, you're getting the second diode conducting, going through the load and going through the fourth diode. So what we see there is it goes like that. And after that point, what you're getting is this will always be positive and this will always be negative. And you're getting something that looks like this when we look at the oscilloscope. It'll just be a bunch of bumps like this. It's always positive like that. Then what we take this into is connected to capacitors. And what that does is it smoothens out the curve. So at a lower capacitor value, we're using 10 microfarads, 100 microfarads, and 470 microfarads. It'll keep getting more and more smooth. So we see that with this blue line here and then the brown line, which pretty much is DC. Afterwards, we put it to a load circuit, which is just a switch, 3 LEDs, and a resistor. And this just shows that we can take the AC current and turn it into DC current that can. Looking at our setup here, first we have just an old wall adapter. This is what you'd plug in, and this is giving us the 10 volts of AC voltage. This we bring to the breadboard, and on the oscilloscope, you can see here, it's just 10 volts of the voltage with the 15 volts of like peak to peak. So that's just what that AC is giving us. And in the circuit here, we have the 4 diodes. What this does what we explained before. It goes in and makes it all positive. This is the capacitor, and we'll put the 3 different values to, at that point, it'll turn into DC voltage. And then this is our load circuit, our 3 LEDs and the resistor. This just will power once we turn it all on. So now we'll move the probes over to show some of the different things. So starting with this one, and then second probe, same thing, and we connect it to the other side. And this is after all 4 diodes are being active. It's just all positive and giving us every single peak. Okay, so now we're looking at the DC output voltage. We're seeing the first probe is just looking at what's coming out of the diodes, and then the second one shows the DC. Right now it looks pretty much just like DC, but once we turn on the load, we see that the capacitor in action that's like trying to smooth out the curve a little bit more every single time. Now what we'll do is change the values of the capacitor to show it in action and see how it smoothens out to look more and more just like DC. So starting with our next highest one, this one's 100 microfarads. It's getting more smooth, more flat, but there's still a couple of bumps. And then moving on to our really large capacitor, this is 470 microfarads. This one, it'll just turn into pretty much flat DC voltage, powering the 3 LEDs.